All right, welcome to another tutorial. This one's going to be on HTTP and really just how JSON and API and the internet work in general and how that's going to relate back to our Flutter app. So we got a demo app here that's going to load some dummy data, but it's going to use the real internet to do that. And we'll see how that interacts with the block, and we're going to use HTTP. So yeah, first off, just going to go over some theory, API, JSON, HTTP methods. So get, post. If you already know plenty about that, it's probably going to be a review. You could probably skip to the second section. We're going to create the models to match the JSON. So this dummy API website I found has employee models, so we're going to model that out. And we're going to see how we can automate that parsing code generation so we don't need to do it ourselves. Then we're going to build an HTTP client with the plugin. So we're going to wrap that plugin with a class of our own so that we can mock it and use it to test our service later. We're going to build that service, an employee service with the client, right? So it's going to get the employees. We're going to be able to do things like delete them, or pretend to at least. Then we're going to hook up that service with a block and hook it up to the UI and make that UI reactive with the block. And then we're just going to unit test the service because I've went over unit tests in Bloc in previous tutorial. All right, so let's open up the web here and go over what we mean by API and JSON and HTTP methods in general. So first, let's go over API. API is Application Programming Interface. It is a language that two programs are going to talk to each other. So that means two programs being usually a server and an app. So there's going to be data that's sent between the two of them, and the language that it uses is usually JSON. And JSON hosts all of the data in key value pairs, and the value could be a string, it could be an int, it could be a whole lot of things. It could even just be another object which has its own keys and values. So this is the site that I'm going to use, dummy REST API example, and these are the endpoints that it has, and I'm going to go over some more of this terminology in a second here. But first, let's look at JSON. So here's an example. So JSON, this is an example of JSON. So key value pairs in a map, we got name, test, salary, 123, age 23, and then the value can be many different things. It can be an object like we say over here, or it could be an array, and the array could then be anything. It could be a list of insert strings or what have you. So the JSON goes in the body of the request, and that goes and hits what we call an endpoint. So an endpoint is basically a complete URL, and usually it's going to have the version of the API and then some sort of object that you're interacting with, like a business concept, like an employee, and then maybe it's a list or maybe it's just an ID. So this API actually doesn't work very well, which is great because we're going to be able to do a lot of error handling, and also it's not designed very well, so we're going to be able to critique it and get some ideas of how you might be able to make your own API better than this. So first, let's go over the URI. So URI is Uniform Resource Identifier. This is just Wikipedia, and this is a really good example of what we're going to be looking at here. So we're going to need to build this up to build a URI for our client to hit. So the first thing is a scheme. This is HTTP or with an S on the end, depending on your certificates. This website just has the HTTP. And then we're not going to use a user info, but this is valid before an @ sign. So we just have the host, and that is the dummy.restapiexample.com, and then the port. And we don't have a port either because it's just a website. So that entire thing is called the authority, and we're going to put that into our URI class in Dart. And then we have a path. The path is to the specific resource. So in our case, it's just /employees, but we also have the /API/v1, and that's really common because versioning the API is important, because API is very, very hard to edit after it's already created. Usually you just make a new version and upgrade the version. And then we're allowed to put a query after as well, and that comes after a question mark. So an example of this is when you copy and paste a YouTube URL at a certain time. That's a query parameter, so it's going to be like t, like time or something like that, and then a number of seconds or something like that. Then the fragment I've never really used. Actually, I'm not exactly sure what the fragment is. I think it might be for orienting the page at a certain place, like a place in a list. So yeah, we're going to have to build up this URL and put it into a URI class. Let's go back to the API here. So the main methods that we're going to use are all shown here. There are more methods that exist, but these are the main ones because it covers really all of your bases, right? So the bases are CRUD, create, read, update, and destroy. So get is obviously getting something. So you're going to hit employees and you're going to get a list of JSON, which represents the list of employees. Or you can get singular and get employee/1. Here's one critique of this API is that this has an S on the end and then this one doesn't, which might make sense for just English because this is plural. But usually when you make your server, you're going to make like an employees controller, and then every root after this is going to be /something/1/favorites or something like that. And the S would be here as well, and it would be the same controller in your backend. So that's a bit inconsistent there, but it's not a huge deal. But the /1, the /ID, that makes perfect sense. A post is a creating something. It's often also like a command. So like, get me this file or build this PDF for me or something like that. That's often a post. In a post, we are often sending JSON and receiving JSON. You don't need to do either of those things. You can just say 200, okay, it worked. But here's an example, API/v1/create. And this also doesn't make a lot of sense because this should just be /employees. And you know it's a create by virtue of it being a post. So you don't need to put the word create in your URL. You would just send like if I were to make this, I would say create employee is just a post to this URL because it's to the employees controller. A put is similar to a post except it's like an edit. So put is supposed to be omnipotent. Idempotent, which is a weird word that's hard to say, but it means that if you do the same thing over and over, nothing changes after the first one. So you can imagine if you send an edit request, edit this employee to have 1,000 salary or something like that, and you send that a whole bunch of times, only the first one would matter because then you're just telling it to do the same thing over and over again. So conceptually, post is a lot like a create and put is a lot like an edit. Similar to my critique on this endpoint where /create, /update doesn't make any sense because first off, what are we updating? Are we updating employees? It's not clear. And we know it's an update if it's a put, so it would just be a put to usually something by ID. Like I'm replacing ID 1 with a new thing. And it would be a put to this URL, except there'd be an S there. And then delete is self-explanatory. We're deleting something. And again, the word delete should not be in the URL because we already know it's a delete. We're saying the HTTP method is a delete. So let's look at an example. And the example that I have open is a get, and we're going to get an employee 719. So here's the result. And the result payload also doesn't make a whole lot of sense. So if I were to make this API, I would make this the entire response. We don't need the success thing, and we don't need the data key. And also one thing that's a little weird with this example is we're trying to get ID 719, and we got back ID 1. So it's probably just a little mistake on their tutorial thing here, but you would obviously be wanting to get employee 719 back. Another thing that maybe is worth noting is that a profile image would definitely not be sent in this kind of payload. You would request that separately from and get an actual file. You would not want to like base 64 encode a profile picture here. That's going to be way too much data if you get a whole list of employees. So yeah, those are the methods that we're going to use. Now let's look at our plugin for Dart. So that's right here, HTTP, and it's by dart.dev. So what it's going to do is it has methods for each of those HTTP methods that we said about, well, we've already talked about, right? So we got post here, and it needs a URI. So we're going to go URI.parse in this example, I guess, and give it this complete URL, and then you post to it, and then you send some sort of body. So this body is again JSON, and then it's going to give us a status code and a body back. So again, status codes that start with 200 are supposed to be success codes. We're not going to use .parse. We're going to use another constructor, but the idea is going to be very similar. So let's first look at our employee payload, and we can see that it's got an ID, a name, a salary, and an age. These are the ones that we're going to care about. I'm just going to forget about the profile image for now. The other thing that doesn't make a lot of sense about the naming of this API is that employee is self-explanatory. We know it's an employee, so we don't really need this extra stuff here. It could just be name, salary. I think that would be a little easier to just understand. A little cleaner. But yeah, let's model that JSON. Let's get the app up here. So to model it, what we're doing is we're just going to make a class that hosts all of the data that we expect to come back. And we're going to have to make sure that things are either nullable or not, depending on whether we expect them to always come back. So in this case, nothing is nullable. But if, for example, somebody, you don't know their age, maybe they just didn't disclose it. If this is nullable, you're going to have to make it nullable, or else your parsing is going to crash due to null issues. So yeah, we have an int ID, string name, int age, int salary. And we saw there that the keys for the JSON are not the same as our variable names. So in order to declare that this one has we know that its key is different than the name, we need to add this JSON key annotation and give it the name that we think it's going to be, which is employee name. And then on top of this class, we need JSON serializable, and that also has some extra options that I'm not going to go over, but you can just control click it and read the documentation if you want. And what's going to happen is we are going to have these generated methods generated for us, and they're going to start with this $_, and they're going to handle all the nitty-gritty of creating and parsing the classes from JSON. So here we have employee from JSON. This is generated code. Do not modify it. I'll show you how to generate it in just a second. So it's going to make us an employee, and it's going to pull out everything based on the keys, and it can do some really complicated stuff, such as if an employee it could do a list of employees. It could do like a company, and that would have a list of employees nested in it. It can do pretty much whatever you need, as long as everything inside there is JSON serializable. So we're going to, in order to be able to do this, what it's going to look like when you first write this class is this file, which is .g, is not going to exist. So let's just delete it. And this thing is going to complain to you. So you need to remember to put this here, part. So that's going to put part of this file in another file, and it's going to be this generated file, which is going to have this convention with the .g after. In order to generate that file, we need a couple dependencies, and the dependencies that we need are dev dependencies. We need build runner to build the files, and we need JSON annotation in the actual code. So to build that, I have the command copied in a comment here. So it's a very long command. I like to put it in a comment so that I can copy and paste it, put it in my terminal. The delete conflicting outputs is going to overwrite every single file that was generated before, which is usually what you want. You don't just want the complete new versions. And it's also going to generate us some mocks for later, but let's not look at that just yet. So once that succeeds, it takes a second to realize that it created the file. Let's just control click here. Oh my god, finally. Okay, sorry about that. I don't know why, if IntelliJ didn't know that file got created, but here it is. It's the same as before because I didn't change anything. But yeah, there's our from JSON and to JSON. So we're also going to model out the create employee request, which maybe isn't named the best because we're going to use it to edit employees as well. But it's almost identical, except it has no ID because the server is going to choose the ID when it is put into the database. Of course, this is all fake. It's just going to send us back a random int for the ID. But the idea is there. Oops. Okay, so we've created our models. So now let's look at building an HTTP client with the plugin. So that is going to be in services. So we have this my client class. You got to be careful with just calling it client because it's the most obvious name, but there's quite a few different classes named client in different plugins. And also it's useful to use a named import for HTTP because it has methods such that are just called like get. And we're going to define our own get. So this is going to wrap this class. And the reason that we want to wrap this class is for unit testing so that we can mock our service, and also we can add a bunch to it that's going to make our lives a lot easier in managing the URLs and the user agent and stuff like that. Okay, so there's 4 methods that we're going to do. We're not actually going to use all of them in the block, but we are just going to write them all out here because that's what we want to learn about. So here's the get. Usually you're just going to hit get as an endpoint, but you also might have query parameters if you just need them for that particular request. So here's an example, YouTube, with the time at 1299. The query parameters are after the question mark. Then we're going to have the post, and the post needs the payload, the JSON that we're sending, and the put is the same thing. And then the delete, we are just hitting an endpoint. So each of these are going to return a response, and response comes from the HTTP plugin as well. Okay, so here's my client, and this is a concrete class that implements this client up here. And here's what it needs to take in: a base URL, a user agent, and an API version. And with these things, it's going to build a URI for us to hit, and then it's going to build like a base part, and then we're going to be able to put something after that with like the employees /1 or whatever we need to do. So this is the version string. It's just v1 or whatever. Headers can be included in any request, and they probably would be in a real app because you would have authorization, and authorization very often goes in the header in the form of something like a token. So I just put this here. This is a real, in quotes, JWT token is in the format is correct. It's 3 parts separated by dots, and they're very, very long. Maybe we'll go over tokens in more detail in a future tutorial, but just keep in mind this is probably where it is. It's going to be token and then the token, or like bearer and then the token. And that goes in the headers, and this is how you would do that. The user agent is really, really useful for your own managing your own server. So let's say that you had your user agent as like your app version and also like the platform. So it's like iOS 1.0.2. And you see all of a sudden, you know, there's a whole bunch of failures from a particular version that could alert you that maybe you broke your API or something like that for an older version. And just really helpful to know if like particular devices have issues as well. It can help you with hunting things down. And then the content type we're going to need for the JSON. So this lets it know that yes, this body is JSON. Okay, so here's a method to build a URI based on an endpoint that we want to hit. Actually, maybe that's not named the best because the entire thing you would call the endpoint, but I'm not going to change it now. And then optionally, we can pass in some query parameters. So we're going to use the HTTPS constructor, which needs an authority, an unencoded path, and then optionally query parameters. So the authority is our base URL. So that's going to be the URL that we went over on the dummy website. And then our unencoded path is going to be API/version/endpoint. Yeah, so that's going to be used in every single one of the methods and the overrides. So delete, we're just going to call delete and pass in the headers. Get is pretty much the same thing, except gets can have query parameters. I guess they all could have query parameters theoretically, but gets usually are the only ones that have them. So I only put them on the get. Post, very similar, except we're sending a body. And we need to use JSON encode to send that. So JSON encode comes from Dart convert, and it's going to convert it into a JSON string for us. So it knows how to take a map of anything and encode it. Very, very important to do this, or else it's not going to be JSON. It's just not going to work. Then the headers, and then the put is identical except for it's calling put. Okay, so that's just about it for our HTTP client. It's really not that complicated. And next we're going to show you how to use it, and we're going to use it in a service. So I think it's really important to split these things up into layers. The layers being like a HTTP layer, and then like a data layer. Like this is me getting employees and parsing them, and then a state layer. The state layer is like the block. And each one we like to separate with interfaces. So that's why this my client has an abstract class. So this behaves like an interface. So my employee service, scroll up to the top, is going to need one of those clients. First, let's look at the interface actually. So these are the 3 methods that the block is going to use. I'm not going to deal with editing them for this tutorial, but it would be very, very similar to creating them. So this, instead of dealing with JSON and really low-level data stuff, it's going to map it into our classes. So get employees is going to simply get us the list of employees. And all these things are going to have to be asynchronous because they happen over the internet. So it's going to need to be a feature. And then create employee, where it's going to take in the create employee request with the name and stuff like that and give us the employee. And this employee is going to have the ID of the thing that was actually created. And then delete employee doesn't need to return anything because we're going to have an exception if it fails. So we're not going to deal with like an error like class or anything like that. Oh, that was weird. Sorry. It uses an ID. Okay, so this is the concrete class for this service. It's a dummy employee service just because dummy is in the name of that website. And it needs a client. And this is the interface, right? This is not the concrete class. And that's going to be final. It's going to be passed in the constructor here. And I also have this helper method here because it's nice for the tutorial. So I'm going to build my client with that base URL, a fake user agent, tutorial app, and then app version. And then our API version we know is 1 from the website. So this is just like a helper method. if you had a real production scale app, this might be in some sort of config file. Okay, so first method, get employees. It gets us a future list of employees, future meaning it's got to be async. And it's going to be really simple. It's just a try catch, and it's just a try catch that wraps that client call. So on any exception, we're going to format that. We're going to reformat that to a new exception. So we're just going to get the response from the client. We got to use the wait keyword because we're trying to get the actual response, not a future response. And all we got to do is pass in the endpoint that we want. So this is going to be the stuff that's after v1/employees. That's what we want. Then what we're going to do is get JSON, and it's going to be in the body of the response. And we're going to have to decode that. So this is going to be a map, and it's going to be a map of, oh, it's actually just dynamic. Generally, it's going to be a map, though, which is why I access it with the data key. So just remember that most APIs are not going to have this weird thing where you access it with the data. This is kind of silly. Usually, the response would be the data. We don't need to access it with the data. And we're just going to, we know that it's going to be a list. It's going to be a list of employees. And when it's a list, it's going to be a list of maps. And each map is going to represent a singular employee. So we're going to map that JSON and use that from JSON generated method for us. Sorry, this is the one that we wrote that just points at the other one. And then it's going to cast to list and return that. Let's look at the format exception. So this is catching anything, and we're just going to rethrow. So I like to catch absolutely everything and then rethrow it with a type of exception that I know about, so that other things that consume this don't need to catch a million different types of exceptions. They can just catch one. So this is just taking the exception and mapping it to a new class, which is mine, employee service exception, that's just going to have a message. And that's all. So a socket exception means there was no internet. This could mean that your user is offline, or it could mean that your server is offline. Both are going to be socket exceptions. An HTTP exception is something with a failure status code, such as 404 or 500. So you're going to have to handle that in your UI. You know, you're going to handle a 404 a lot differently, which is not found, than an actual crash, right? So I didn't do that in this tutorial, but just keep in mind using that response code and capturing that somewhere is going to be important. A format exception is when the JSON fails to parse. So let's say that we got something back that's not JSON at all. It's just a string. Just a raw string is not JSON. It's got to be a map. Then we'll say bad response data. And then otherwise, we're just going to go unknown error. And we could add to this if we have more exceptions that are happening frequently. But the point is, the only thing this can ever throw is this exception that we know about, which is going to be catching it elsewhere a lot easier. Okay, so let's get employees. Create employees, very similar. We got to pass in the request that is going to house the name and the salary and stuff like that. And then we're going to hit /create. And as the body, we are going to send request.toJSON, which puts our model into a map, and it's the format of the JSON that the server expects, obviously. Then we're going to get JSON back, and it's going to be in the stupid data key again. But this is the same, except it's a singular. So we know that when we get a singular back, it's going to be a map, and we're just going to map that one thing back. And then same thing, format exception down here. Delete employee is even simpler because we don't need to parse anything. We just know that if we get a successful status code, which is like 200, then we're just going to assume on the client that it worked and that employee is deleted. Okay, so that's everything for our employee service. Let's take a back look again at the lesson plan here. Okay, so we've built our service with our HTTP client. Now we're going to use this service in a block. And that block is going to be a qubit, which is a class that extends block. And I went over blocks in more detail in the previous tutorial. So we're going to just go straight into the methods here to use the service. So we got to pass in the service. And again, this is the interface. This is not the concrete one. And let's look at create employee first. So first off, you can choose where to do your debouncing. I like to do it in the block itself. But if you imagine somebody just spams the create button, each one could send a request, and we don't want that. We really only want one employee to be created at a time. So if our state, which houses this, is creating employee flag, is true, then we're just going to return null and we're not going to do anything. You know what? Let's take a look at the state first. So here's the employee state. The state goes into the block, and this is what we mutate to show the state of our employees, obviously. So what we're going to have is a map of the employees. So this is their ID, and this is their user model. This model still has an ID, but it's just really convenient to have a map so that you can just go employees and then square brackets 1 instead of using like list.firstWhere or null all over the place. This is just a little more convenient. Deletion loading map. So this is where we're keeping track of which employees are being deleted. And the way that I've set it up is so that multiple can be deleted at the same time and have their own independent kind of loading states. So again, that's by ID. And then we have just a singular Boolean for whether we're loading the entire employee list, a singular Boolean for if we're creating employee. So we've just decided that the user, when they're using this app, they can only create one employee at a time. Well, there's one operation at a time. And then recent error. So I've decided this is the most recent error that's happened. So let's say the list fails to load, it'll have an error. If then creating an employee fails, it'll replace that error. If you wanted to, you could split up the error for every different thing that could happen. I didn't, but you definitely could. You could have an error message for creating and loading list, and for each deletion could have their own error if you really wanted to. Got some getters for has error and whether we have any employees at all. And then a little helper for accessing the map in a null safe way, because when you access this map with ID and you're looking for a Boolean, that could just be null. So we're checking if this is true, and actually true, not just null or something like that. And then that makes it into a bool that's not nullable. So we got an internal constructor and then the initial state where we don't have any employees, nothing's loading, we have no error, and nothing's loading. And then we're going to mutate that with the copy with pattern. And then we have the toString down here. Let's go back to the block here. So that's our state. So the first thing that we're going to do is that we're going to mutate the state to show that we're loading. We're going to mark this as loading with this flag here with the copy with. So we're creating an employee now, and we're going to clear that error because there could be a new error from this operation. And then we're going to wrap the call to our service with this try catch. And this is going to catch the employee service exception and also unknown errors. So I still like to catch, and like I have a catch all here. This is an unknown error, and like I said in the previous tutorial, this is a really good place to log to Sentry, log to Teams, log to Slack, something like that, because if this is happening, you have no idea why this is a bad crash. Okay, so let's from the top here. We're going to call service.createEmployee. That returns us an employee model, a future employee model. We're going to await that. Next, we're going to get our map of employees that we know exist, and we're going to copy it. It's really important to copy maps instead of mutating them directly, because if many different places are changing these maps and mutating them directly, you can have some unexpected stuff happen. So you would like it to be a new instance, and this goes along kind of with the copy with pattern. We're copying it. So we're going to, in that map, we're going to add that new employee, and then we're just going to emit the success. We're no longer creating employee. This is our new list of employees, map of employees, and then we're going to clear that error. This is a bit redundant, but I think it's okay. Then if it fails on the service exception, we know we have a message from that exception, and then we're going to show the recent error. And we're no longer creating an employee, and same thing here, except it's an unknown error. Okay, let's go down to load employees. Same thing, we debounce. If we're loading the list, we just return. So we mark the list as loading, and we clear the error. And then we do a try catch, and it's the same idea, except of course we're calling get employees, which returns a future list of employees. So then we get our list of employees that we already know about from state and copy it again. And then we add every single new employee that we get to that map. Next, we go and say we're not loading anymore. We give the map of all employees, and we clear that error. And the error handling is the same as before. Deleting is super similar again. We debounce. This time, however, we're debouncing it for that particular employee. So you can delete multiple employees by tapping their list tiles really quickly, and I'll show you that in a second. So we get that map, and we copy it. We assign the existing deletion is true there to that particular ID. And then we got to omit and mark that we're loading. This is our new loading map, and we're going to clear the error. Okay, next up we're calling service.delete employee, which needs the ID, and that does not return us anything, so we just have to assume that if it didn't throw, that it succeeded. So we get all the current employees and copy that over, and we just remove that one that we just deleted. Then we mark the deletion as no longer loading, and then we just omit all that new information. We are omitting that we have a new deletions map, a different employees map with that one guy removed, and then we're going to clear that error. The catching is slightly different because we have to mark the deletions as not loading via ID, but other than that, it's pretty much the same as the other ones. Okay, so that's our block. Let's just try out the app a bit. So I'm going to open up the UI, employee screen. So we got a block builder. This one is going to be stateful, and we're going to have an error stream. So when things fail, we're going to be able to get a dialog, and things do fail with this test API a lot, so just be aware of that. It's not my fault. So first let's load the list. So that button, when we have a loading state, it shows a little loading icon. So we got a whole bunch of users, and they're in a list view. And now let's delete one. Let's delete a bunch at once. And then pop, 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 they all go. And let's create one. Oh, I created it, nice. And then that puts it at the bottom of the list. Okay, let's keep going until it fails. Error, bad response data. So very, very often this API, because I'm assuming a whole bunch of people use it, it gets an error code of too many requests and it fails. So you can see this is the error emitting. So let's look at how this dialog happens first, because that's the first thing on our screen here. So in our init state, we are going to have an error stream, and it's going to subscribe to the state of the block, and it's going to map that to the error, and whenever we get a new error, we're going to show that dialog. So we go here, and this is the method to set up the stream. So the error stream, we're going to listen to the employees qubits stream. We're going to map that stream to recent error. So just like a list, you can map the elements of a stream to a new type, and then we're going to listen to that. So listen gives us a callback to do something every time we get a new recent error. And because we've mapped that to a string, this recent error here is a nullable string because the error could be cleared, right? It could be null. So if it's not null, we're just going to show a dialog, and we're going to say error, and that's the recent error. And then the button just says OK. So just like that. Okay, let's go back up here. So that was in the init state. Error stream, stream subscription. This will keep listening after this widget leaves the tree. So you got to remember to dispose that if you want that to go away, which you almost certainly do. Okay, let's go to the block builder. Block builder looks up the employee's qubit and employee's state, and then we're going to be able to build the screen based on that state. So the app bar is always the same. It's just HTTP tutorial, and then the body is going to be a builder, so I can write some code in these brackets. And we're going to do some checks on the state. So if there's no employees at all, we're just going to have no employees loaded. This is like the initial state of the app that you saw at the start. If we have any employees at all, even if it's loading them again, we're going to show what we currently have. Oh, that time it failed to load the list. And this has to do with reactive UI. So when things are happening asynchronously, you really, really don't want to make your user wait for it because it feels slow. Even if it takes the same amount of time, it feels slow. So imagine if I hit delete and then scroll down, if I wasn't able to do that and I had to wait for just wait with the loading screen, every single time you do anything, your app is going to feel like it freezes. It's going to feel sluggish, even though it actually might not take any more amount of time. So while it's loading, I can still scroll around. Nothing's locked up. That's the beauty of block and asynchronous stuff, and you can make your UI reactive really easily. Okay, so we got a list view.builder, and each employee that we have in state is going to go into a list tile. So we're going to get the element at I. List view.builder is good for long lists because it builds them lazily. You could have a whole bunch of employees here. And we're also going to figure out if that particular employee is being deleted. So that's how this icon knows whether or not it should be the delete button or the more horizontal. Each list tile just has the user's name and then their age and their salary there. And we're just assuming that the salary is in dollars with just 0 cents at the end. And I've debounced it here as well because it's debounced in the block. Maybe this is a bit redundant, but it's okay. Okay, next let's look at our float in action button row, and this is going to have the create and the refresh buttons. So we got two of them. When you have two widgets that can have a hero tag, you have to explicitly set them to null, or else you're going to get a weird error that says multiple widgets have the same hero tag. So neither of these have a hero tag. It's for a hero animation, but we don't need that. So the create button creates a random employee. And if it's creating, we're going to show that loading thing. And if not, we're going to show the add button. So let's go down to create random employee. It's just going to get a random int and go create employee with employee I and their ID, sorry, not their ID, their age is the same as their number there. Let's create a new one so that it shows up. 701, he's 701 years old, and his salary is 100 times his age. So one thing that I really like about the block pattern here is that we can wait for that operation to be done by simply returning a future employee and make it nullable here from create employee. So if it succeeds, we're just going to return that employee here. I think I actually missed that earlier. So that's really, really useful because we can wait in our UI for that to be done loading for something that actually requires like waiting. You do actually need to wait for this to finish, even though we want a reactive UI. We can't show a dialog until it's actually done. So if it's not null, meaning it succeeded, we've created it and we just show a little dialog. Okay, next up, let's look at the delete one. Sorry, the load one. And this one just calls load employee. It passes this method into onPress because it's got the same function signature. And if it's currently loading, then we just show that more horizontal thing instead of the refresh. And it really doesn't want to load more. Okay, let's take a closer look at the delete one. So the delete has a trailing icon button that deletes the employee by ID. What I want to try to explain to you is how this stuff is working where you can delete a whole bunch at once. So let's look at the employees qubit again and look at delete employee a little closer. So we debounce it for that particular employee, but you got to remember that this works by ID. So if we delete like 5 of them, because this is asynchronous and all these things can happen in parallel, we're able to show that each one is loading individually and have each one resolve individually. Now the errors aren't individual just because I chose not to make it that way. But as you can imagine, we can just call service.delete employee without the await with 50 different people, and each one is going to ping off individually. So because we're capable of doing that in code, it's really nice to make your UI reactive like that and really fluid. Now, of course, if it was a delete thing for real, you would probably want a dialog because you don't want them to be able to delete just like 50 people willy-nilly like that, maybe. But for certain things, it is really, really nice to have all these things working in parallel and make sure that your UI is only locked up in the smallest place that it needs to be, right? The smallest place that this delete needs to be locked up is just this one icon button. We don't need to prevent them from hitting create, and we don't need to prevent them from reloading the list. So in your UI, you really shouldn't if you have the ability to. So that's what this map is really, really useful for. Okay. So we've used the service in a block and we built our reactive UI. Now let's just look at some unit tests. We're just going to unit test a service in this one. I've already shown you how to unit test a block. So unit test, first off, just like the block, we need to make some mock classes. We're going to mock the client, and I would normally mock the service as well so that I could test other things, but we're going to test the service. So this isn't actually needed for this tutorial, but normally you would just mock pretty much everything so you can test whatever you need to. Again, we generate these mocks with this command. That's going to regenerate mocks.mocks.dart and these two generated files in the same time. Okay, so let's go to this test. So what we want to test is that it handles HTTP responses properly and in an expected way. So we can do that by mocking our service, right? So we can make a mock my client and make it return anything that we need to. And this is great because it means that we can effectively mock the server and also the situation, right? Like we can mock them just being offline if we just didn't return a response whatsoever, something like that, or a socket, or through a socket exception, really. So we're going to put these in a group and we're going to put the class name there so that it prints nice on the console. And the first test is just going to test that it throws a service exception if the response body cannot be parsed. So we can see here that the response has not JSON, but it succeeded. So what's going to happen is that it's going to try to parse this into employees, and it's going to fail. And we're going to expect that this method, when we call it getEmployees, throws an instance of employee service exception. This is a little weird. We need the isAF for matcher, and we also want a throws. So we know it throws that type. Okay, next one. We're going to test that getEmployees parses a payload into a list of employees. So we're going to be able to mock the employees that our API is returning. So we're going to mock that client and then use a concrete employee service and pass that in. Here's the expected employees. These are the two people that we're sending, ID 1 and 2. They have the same name. For this test, it's really important, for testing the equality of lists, it's really important that you have an equality operator on your model. If you don't have this, it's not going to think employees with the exact same data are equal, and this test is not going to work. So just be aware. This boilerplate is quite annoying, but it's very, very useful for tests. So here we're going to, when we get any, meaning, actually this should be, when we get anything, meaning any call to get, whether it's a list or whether it's by ID or anything, we're then going to answer with this response, and this response is going to encode our data. And you just got to remember that this API is dumb, and see how many times I have to put this data key. This is really, really fragile and really annoying, because imagine if somebody changed this, everything is going to break. Usually changing API, everything's going to break, but this is something you might actually want to change because it's dumb, and then it would also break. So don't do stuff like this. Make your employee make all of those keys just top level. It's a lot easier. We're going to see this is just everywhere. But yeah, so we take our expected employees, we put them to JSON, and we encode it, and then we send it back so that we can actually get this stuff into JSON, and it's returned by our get. So we get our employees, and this time we expect that employees that we got from the service matches this list that we made up here and told our client to respond with. So let's run those tests. And they're in a group, and they pass, which is great. Okay, yeah, so that concludes the tutorial. So in this one, we went over API, JSON, and HTTP methods fundamentally. We created models to match our JSON from that dummy website. We built an HTTP client with the HTTP plugin. Then we built a service around that client, or we built a wrapper. And then we built using that service, we used in a block. And each of those three layers are separated by an interface so that they don't care about how the one that they're depending on is implemented. Then we built the reactive UI with Bloc, and then we unit tested the service.